So today we are going to look a little bit at the way it's arranged, looking at some different trends, and this guy named Dmitry Mendeleev, my name. I'm an old guy. Anyway, I decided to go ahead and categorize everything in a periodic table and arranged it, mostly looking at what are the similarities of properties. So we were looking at these is how I kind of arranged it. My group, when I did it, we did it based on so when Dmitry did it, he arranged it based on increasing atomic weights. So these were the two things. Come to find out, he was so brilliant that he was able to predict with his periodic table. There was 3 unknown. He left some blank spaces. So these blank spaces ended up corresponding to some unknown elements. Pretty cool. All right, so now let's look at what are. All right, so here's our modern periodic table, and our modern periodic table is organized based on some very specific things. So if I want to look at what are groups, so we can look at groups. So anything in the same column we call a group. And anything in the same row. So let's take this row here. So going across, we call that a period. All right, groups can also be called, so these groups can also be called families. And those are some things that we'll look at. So that can also be called families, looking at the same groups. All right, so there's some very distinct things when we look at groups. So first thing we want to look at is when you look at your periodic table, it might say 1A, 2A, 3A, and going across 4A, and so forth and so on. So 5A, 6A, 7A, 8A. All right, so any element that is in the same group is going to have the same number of outer shell electrons, and that term we also call valence electrons. So if I can write the word valence there. So if they have the same outer shell electrons, it means they have the same valence electrons. So what does that really mean for us? So anything in group 1 has 1 valence electron. Anything in group 2 has 2 valence electrons, or 2A. 3 has 3 valence electrons, 4, 4, and so forth and so on. And because they have the same valence electrons, it is why they have the same chemical properties, because all we care about is what behaves on the outside. All right, so looking at periods, or things, remember, those are the rows going across, and on the left of your periodic table, it lists it from 1 through 7, 1, 2, 3, 4, 5, 6, 7. So the periods correspond to the number of shells, the number of outer shells. So anything in the same period, the electrons, each contains elements with electrons in the same outer shell. So for instance, in row 1, they go into having 1 ring. In row 2, they have 2 rings. In row 3, they have 3 rings. So now we got to look at what are some different other groups, or things that we kind of call each little family. So we talked about how groups are arranged into families. Well, group 1, or group 1A, here, whole group. All right, so we talked about how different groups are arranged slightly differently. So we're going to look at this first group here, or first family. So we said how groups, so in your periodic table it'll say 1A. This whole group here is called the alkaline metals. So lithium, sodium, potassium are called alkaline metals. All right, so if I want to know what is this next group, they also call this group, or family, this family is called the alkaline earth metals. So those are the alkaline earth metals. We can call this group down here, which we know to be the the things that have d orbitals. This whole section here are called the transition metals. So those are called the transition metals. That are called this group is called the halogens. So that's the halogens. And this last section down here in the very end are called the noble gases. Okay, those are often referred to as the noble gases. They have 8 full valence electrons. They have a full octet of valence electrons. All right, other piece we want to look at is describing what are metals and what are nonmetals. Where most of the periodic table, hydrogen's a weird guy, but most of the periodic table, so all of this whole section, including through here, and there's like a little staircase here. So everything in this whole entire section are categorized as metals. Everything over here on the far right hand side are categorized as nonmetals. Okay? And then there's a little tiny section right above above the staircase. So on this little staircase thing, so above and beneath the staircase, we call those metalloids. So those are categorized as metalloids. So those are the ones that are kind of like above the staircase and below the staircase. They're called metalloids. Alright, for metals, most of these, vast majority of all the elements on the periodic table are metals. Let's just look at some of their general properties of metals. Well, metals we know have what we call their luster. They're really shiny. They're good conductors of heat and electricity. They have a really high density, a high melting point. They're ductile. That means most of them can be drawn out into thin wires. And you guys do need to make sure that you know each one of these. They are also malleable. That means they can just be hammered into thin sheets. Chemical properties, they do easily lose electrons, and they usually, most of them have a high corrosion or general wearing down. So those are some of the properties of the periodic table for metals. Alright, for nonmetals, which are a small little section, they're usually dull. They're very poor conductors of heat and electricity. They're usually very brittle. So for instance, like sulfur. Sulfur, you can just basically crack it in your hand and smush it all apart. So because of that aspect, we can't make wires out of them. We can't hammer them into any kind of thin sheet, so they're not malleable. They generally have a low density and a low melting point. Nonmetals always gain electrons. So they have a tendency to gain because they have a higher number of valence electrons. And they tend to join up with metals. So these two compounds called ionic. So when you have a metal and a nonmetal, so for instance, if I have sodium, which is a metal, and chlorine, which is a nonmetal, when they join together, sodium has like an extra valence, so sodium has 1 electron, and that's how we indicate that, in its outer shell. Chlorine, it's a group 7A, and it has 7, and so that's how we indicate that. And so what often happens when these join, sodium, because it doesn't want its electron, and chlorine wants an extra electron, sodium will actually donate this 1 electron to chlorine, and they become a compound, and this we know as table salt, sodium chloride, or standard table salt. And that is an ionic, what they call it, and we'll talk about that later, that is called an ionic compound, because it makes ions. And that is it for part 1. Please continue watching periodic table for part 2.